everyone, this is your math guru. In this video, I'm going to show you how to use the cast diagram to solve the following trigonometric equations. Please don't forget to click on the like and the subscribe button below for more easy to understand math concepts. In the first example, we have if sine theta equals 3/5 and 0 degrees is less or equal to theta and theta is less or equal to 90 degrees, we are to determine by means of a diagram cos squared theta and 2 tan theta. As stated earlier, we're going to use a cast diagram to first of all determine which quadrant we have our triangle. So we start with the first condition that says that sine theta is equal to positive 3/5 and we have 0 degrees is less or equal to theta, which is less or equal to 90 degrees. We know that using our trig ratios, we use the acronym SOHCAHTOA to remember the value of each trig ratio. So in this case is a sine, which is opposite over hypotenuse. So what that means is we have sine theta, which is equal to 3/5. That's equal to our opposite over hypotenuse. Going back to our cast diagram, I'm going to draw my Cartesian plane. We have a cast diagram that's divided into quadrant, and we have it starting from 0 degrees because this is a 90 degree. So we have that as 90. That's another 90. 90 plus 90, that's 180 degrees. If we had another 90, we have 270 degrees. And the last 90, that will be 360 degrees. The next step is to state which trig function is positive in each quadrant. We have a first quadrant, 1, a second quadrant, a third quadrant, and a fourth quadrant. In the first quadrant, we have all trig functions positive, so I'm going to call that my A. In the second quadrant, only the sine is positive. In the third quadrant, we have tan to be positive, and in the fourth quadrant, only cosine is positive. So that's where we get, or we got our cast diagram from. That's CAST. So going back to pick, we need to fulfill the two conditions given. The first condition says sine theta is 3/5. 3/5 is positive. So if you go back to our diagram, we need to pick the quadrant where we have sine to be positive. That will be the first quadrant because all the functions are positive, and the second quadrant because only sine is positive. Note that sine is negative in the third and fourth quadrant. The second condition, so we've been able to fill the first condition. The second condition states that theta is greater than 0 degrees. However, theta is less than 90 degrees. If you go back to our diagram, theta is greater or equals to 0. So we fall into the first quadrant because as soon as we pass the first quadrant, then a value of theta will be more than 90 or less than 180. But we have to stop at 90 degrees as shown in the condition given. So what that means is a diagram, that's the terminal angle or the terminal arm of a theta will fall into the first quadrant. So I'm going to draw that as shown. That will be 90 degrees. Always rule to your horizontal or your x-axis. So we have that as theta. And if we label all the sides, we have the side facing a theta, that's the opposite, that will be O. The longest side is a hypotenuse, and the last side is a adjacent. So what we've stated earlier, we said sine theta is 3/5. So that means our opposite will be 3. So I have that as 3, and our hypotenuse is 5. Note that we picked the first quadrant because that is where the two conditions was fulfilled. In the second quadrant, only one condition is fulfilled. So when you're drawing your cast diagram, you need to obey the two conditions given in the question, and you pick the quadrant whereby the two conditions are being fulfilled. So back to our calculation, we've been able to find our hypotenuse, that's 5, our opposite is 3. The next step before we start solving, we need to find our adjacent. And because that is a right angle triangle, I'm going to use Pythagoras theorem that states that the longest side, or the square of the hypotenuse, is equal to the square of the sum of the other two sides. So that will be opposite squared plus adjacent squared. We've been given hypotenuse to be 5, so we have 5 squared equals, our opposite is 3, so we have 3 squared plus a squared. 5 squared, that's 25, equals 3 squared, 9 plus a squared. Making a squared the subject of formula, we have a squared equals 25 minus 9, which is 16. And therefore, to find the value of a, I'm going to square both sides. So therefore, our a is plus or minus 4. That's square root of 16. However, if I look at a diagram, a, or the adjacent, falls in the positive x direction on a Cartesian plane. So therefore, the value of a will be positive 4. It's important to note the side of the Cartesian plane your value falls into, because if a value falls into the negative side, then our answer will be negative. So in this case, our a is positive 4. So we can now go back to our question, which says, 1, find cos squared theta. So we have cos squared theta. That's the same as cos theta times cos theta. It's similar to your algebra. X times x is x squared. To find cos theta using our trig ratio is adjacent over hypotenuse. And if I go back to our diagram, our adjacent, we're able to calculate that as 4, and our hypotenuse, that's h, is 5. So therefore, cos squared theta equals 4 over 5 times 4 over 5, which is 16 over 25. The next step is to calculate 2 tan theta. So we have 2 tan theta will be equal to, let's first of all find the value of tan theta. Using our trig ratio, tan theta is equal to opposite over adjacent. If we go back to our cast diagram, the value of the opposite side is positive 3 and adjacent is positive 4. So therefore, 2 tan theta will be 2 times 3 over 4. And if we simplify, that will give us 2 in 2, 1, 2 in 4, 2. That's 3 out of 2. Let's look at the second example. In the second example, we have if tan theta equals 5 over 12 and sine theta is greater than 0, that's the two conditions we have to fulfill in order to determine which of the quadrants will have a terminal arm. We have to determine by means of a diagram 1, 13 cos theta and 2 cos squared theta plus sine squared theta. We have to start by drawing out a cast diagram whereby we fulfill the two conditions given. So we have a cast diagram as shown. I'm going to start by labeling all the sides. That's 0 degree to 90 degree. Then we have another 90, that's 180. And then we have 270. Because it's a cast diagram, we have all the trig ratio that is positive in each quadrant shown. We have the first quadrant, we have the fourth, we have the third, and we have the second. The next step is to go back to our conditions. We're told, or we're given, tan theta is equal to positive 5 over 12. And using a trig ratio, tan is, that's a SOHCAHTOA, I'm going to write it by the side. Tan is opposite over adjacent, so we have that as opposite over adjacent. Now, tan is positive, that's positive 5/12, so we have to go back to our cast diagram to figure out which of the quadrants has tan to be positive. And that will be the first quadrant and the third quadrant. So I'm going to put my tick in those quadrants. The second, so we've done with the first condition. The second condition says sine theta must be greater than 0. Greater than 0 means sine theta is positive. We know that all the trig functions are positive in the first quadrant, so I have a double tick there. And then we also have in the second quadrant, sine is positive. So I need to pick the quadrant that fulfills the two conditions given, and that will be the first quadrant. So what that means is my terminal arm is going to be in the first quadrant. So I'm going to draw my acute angle. So that's a right angle triangle. And we have a theta as shown. The next step is to label all the sides. We have the side facing the theta, opposite, I call that O. The longest side is a hypotenuse, I call that H. And then the last side will be my adjacent. From the first statement given, that tan theta is 5/12, we know that 5 will be equal to the opposite and 12 will be the adjacent. So going back to the diagram, we have opposite to be equal to 5, adjacent is 12. So before I go ahead, I'm going to find my hypotenuse. Using Pythagoras theorem, we have hypotenuse squared equals to the square of the other two sides, that's opposite squared plus adjacent squared. So hypotenuse squared will be, the opposite is 5, so I have 5 squared plus adjacent squared, 12 squared. That's equal to 5 squared is 25 plus 12 squared, 144. If I add that together, 169. So therefore, finding the square root of both sides, I'm going to have my hypotenuse equals 13. Note that hypotenuse in every or in any of the quadrants is always positive. So now we can go ahead and solve the question given. 1, we have to find 13 cos theta. Cos theta, using our trig ratio, is adjacent over our hypotenuse. And that's equal to, adjacent in the diagram is 12. Hypotenuse, we got that as 13. So therefore, 13 cos theta will be 13 times 12 over 13. 13 and 13, 1. So we are left with 12. For the second part of the question, we have to find cos squared theta plus sine squared theta. If I break that down, that's the same as cos theta times cos theta plus sine theta times sine theta. Let's start with cos theta. We have cos theta, we got that as 12 over 13 from the first part of the question. And then sine theta, I'm going to work that out. Sine theta using our trig ratio is opposite over hypotenuse. Opposite in the question is 5 and hypotenuse is 13. So putting in our values, cos squared theta plus sine squared theta will be equal to cos theta, we got that as 12 over 13, that's adjacent over hypotenuse, times 12 over 13, plus sine theta times sine theta, that's 5 over 13 times 5 over 13. 12 times 12, 144 over 169, plus 5 times 5, 25 over 169. Same denominator, I put that over 169. 144 plus 25, that's 169. So therefore, cos squared theta plus sine squared theta will be 169 divided by 169. That's 1. Thanks for watching. Bye.